Okay, so let us now go through this example of working out the information cascade starting with a set of initial adopters. So given this network, these are the centrality values of the vertices. Right now you know how to get the centrality metric values using the jar file I gave you in module 2. Okay, so now I'm going to pick two nodes that have the largest closeness centrality. Okay, so those are nodes Q, 9 and 10, and let our Q be 0.33, which is one third. Now, given these two initial adopters, I have come up with the fraction of the neighbor nodes that have adopted for each node. So for node 4, it has three neighbors, one of the three neighbors have adopted a decision. For node 7, it has five neighbors, two of the five neighbors have adopted the decision. Node 8 has four neighbors, one of the four neighbors have adopted the decision, and so on. So now, in the first iteration, nodes whose fraction of neighbors who have adopted the decision is greater than or equal to one third will adopt the decision. So in that case, 4, 7, 11 will adopt the decision. Now, because of this change, you have to redo the numbers for the other nodes to compute the fraction of neighbors who adopted the decision. So node 12, it now has two neighbors who adopted the decision, which is 2 over 5. Since node 8 now has two of its four neighbors adopting the decision. So in the second iteration, some more nodes will adopt the decision. That includes also node 3 because it now has one third of its neighbors to adopt the decision. So node 3 will adopt the decision, and because of that, nodes 1 and 2 will now have one half of its neighbors to adopt the decision. So the next iteration, 1, 2 will adopt as well as some more nodes here. And then in the subsequent iteration, the fourth iteration, all the nodes would have adopted the decision. So it takes 4 iterations with 9 and 10 as the initial adopters and Q as 0.33. Now if you start with some other set of initial adopters for same Q, you may get fewer iterations or more iterations depending on the case. Now let us analyze a very important thing called the cluster density. Okay, so we'll do this in a separate video.